Okay, we're going to verify another identity here. So we want to show that sine squared of x over 2 is equal to secant of x minus 1 over 2 secant of x. So I'm going to still start with the left-hand side, sine squared of x over 2. And what this means is sine of x over 2 squared. So we're going to put in the formula for sine of x over 2. So it's plus or minus the square root of 1 minus cosine of x over 2 squared. Now the squared will make either the positive or the negative positive and cancel out our square root. So this gives us 1 minus cosine of x over 2. Now, notice in the end, we want a secant in our answer. So one thing we can do is multiply the top and the bottom by secant of x. Okay, because we're really just multiplying by 1. So we're going to distribute in the numerator, so we'd have secant of x minus cosine of x, secant of x, all over 2 secant of x. Now, cosine of x times secant of x is equal to 1 since they're reciprocals of each other. So this would just be secant of x minus 1 over 2 secant of x, which is what we are trying to show. Now we're going to start talking about how we can solve oblique triangles. So these are triangles that don't have a right angle. Now, to solve any non-right triangle, you need to know at least one side and any 2 other measures. So you could have 2 angles or 2 other sides or an angle and a side. Now, this gives us 6 possible combinations. Some of them we will be able to solve the triangle and find exactly one triangle, and some of them we won't. So let me show you what these kind of 3-letter codes mean and which ones we will be able to do. So we're going to start off with this one that says SSS. That means you're given all 3 sides of the triangles, and what you have to find then are the 3 angles. And this one will work. This one does give, we'll just say yes, it does give a unique triangle. Okay, it gives us enough information, and it will be unique. You'll just get one triangle. Actually, no, that's one triangle. Now, the next thing, someone could give you a triangle with just the 3 angles. And here we run into a problem, right? We were told that we need at least one side. So here, it's not enough information. And that's because you can have similar triangles. So similar triangles are triangles that have the exact same angles, but have different length sides. So if you, for example, if you think about a 45, 45, 90 triangle, you could have a 45, 45, 90 triangle with sides 1, 1, and square root of 2. Or you could make it bigger and have 2, 2, 2 square root of 2. So those are dilations of each other. You can scale them. So angle, angle, angle would not give you enough information. Now the next one, angle, side angle, ASA, means that you're given an angle. Well, you're given 2 angles, and you're given the side that's in between those 2 angles, that they're both on. So that's why we call it angle, side, angle. And this one does give you enough information, and it will give you one unique triangle. Okay, and we'll actually end up using, we'll learn 2 different things, and we'll use the law of cosines to solve angle, side, angle. Okay, so that's for angle, side, angle. And for side, 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 we'll also use the law of cosines to at least start solving it. Okay, so the next one, number 4, would be side, angle, side. So here you're given 2 sides and the angle that's in between them. Okay, and this one we can solve, and it will give us one unique triangle. Okay, and it's another one where we will use the law of cosines to start. Okay, the next one's angle, angle, side. So you're given two angles, and one of the other sides, not the one that's between it, because that would have been angle, side, angle. So like this. And this is enough information, and it will give you one triangle. And this one will be able to use the law of sines. And then the last one that unfortunately is going to be your least favorite is side, side, angle. So that's where you have two sides and one of the angles that's not between it. So let's say here. And this one's truly a pain. It does give you enough information, but it's a really special case where sometimes you'll have 0 triangles that work. Sometimes it won't work. Sometimes you'll have exactly one triangle, and sometimes you'll actually have 2 possible triangles, and you'll be expected to get both of them. So side, side, angle is really a pain. Okay, so those are kind of the 6 possibilities if you're given 3 things. Angle, angle, angle is never enough information. Side, 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 angle, angle, side, and angle, angle, side will have very direct paths of being able to solve. And side, side, angle, well, I should put here that we'll use the law of sines, but we'll have to be very careful about how we go about doing it.